Okay, let's do a quick video on building regressions, very simple OLS regressions in Excel. Here we see dataset 1 that we've been playing with. Basically, this is observationally state data for 2018 pulled from a various Federal Reserve Bank, some other places, so that we can explore sort of simple regressions of economic size, in this case operationalized as GDP. Okay, so as we have done with all our visualizations and the like, first thing we're going to do is copy over the data we're playing with. I'm going to pull state, GDP, and manufacturing, which is manufacturing employment in thousands. And this measure of GDP is in millions of dollars. So you can see they're fairly large numbers. So actually, I'm going to convert GDP into GDP billions by dividing each value by 1,000. So that shifts us from GDP millions to GDP billions. I can then highlight this and use Control D to copy that down. So the formulas just get copied straight down. So now I know which state is referring to each one. I have GDP billions and I have manufacturing. It is entirely possible that your version of Excel does not currently have the analysis tool pack installed. This is a fairly simple thing to fix. Go to File, Options. You get this fun window. Isn't Microsoft easy to use? Add-ins on the left side. And here you'll see if your analysis tool pack is currently active or inactive. So mine is active, but if yours is inactive, you would go to Manage, make sure it says Excel Add-ins in the dropdown, and click Go. And then check the box next to Analysis Toolpack. When you hit OK, it will then install it, and you should be good to go. And you'll find that in the data ribbon, and we'll go there in one sec. Good rule of thumb, first thing we're going to do, we're going to make a scatter plot. We want to visualize the relationship between our data. So I want to highlight these two columns and insert a scatter plot, but as I'm learning painfully, Excel expects the outcome variable, our y variable, to be to the right of our input variable. So since we're trying to explain GDP billions, I'm going to move this over here. So now I have manufacturing to the left of GDP billions. So I can highlight these two columns. I can insert a scatter plot. And now I can visualize our data. Always a good place to take a look. This will give you a hint at, did you not realize something hinky about the range of the dependent variable? Are there nonlinearities evident? Are there outliers we're going to need to think about and how they mess up the line? Excel will also let you add in a trend line. You can do it through the plus, but I'm finding out that my Mac users, it's easier if you go Design, Add Chart Element, scroll down to the trend line, and add a linear relationship. So that's how we get our scatter plot. We've done those a bunch of times, and we can see there is, generally speaking, a positive relationship between GDP and manufacturing employment. If you were going to submit this for a report, we do all the things that we've talked about doing, adding axis labels, making sure the range on the axes is clear, and on, and adding an informative title. Okay, so we have our scatter plot. Next thing we want to do, I'm actually just going to move that out of the way. Let's go ahead and build the regression. So here's where we're going to use that tool pack. So in the data ribbon, you should be able to find a button called Data Analysis. Select that, and then you might have to scroll through. For some reason, mine always thinks I want to do a Fourier analysis. I don't know why. Click on Regression and hit OK. That pulls up this window. Interestingly, it's already populated everything that I populated last time. That's less than ideal for walking you guys through this. Yours is probably blank. I apologize for that. So here I will quickly, let's erase all this. This is what it should have looked like when you open this the first time. Blank Y and X, nothing selected, and it's going to output to a new worksheet. Just like we did for making or adding series for individual box plots and things like that, you're going to specify your information. So the Y is what we're trying to explain, which is GDP. So I'm going to go from E1 to E51. The X is manufacturing, so I'm going to go from D1 to D51. Now here's an important point. I have included the labels, so you have to tell Excel that you've selected the labels. Do this because that way the tables that it produces will actually have the labels in them. Otherwise you have to remember where everything is, and it's a pain. So select your labels. I'm going to choose an output range, and I'm going to put my results right here. J1 just sort of off to the side. And I want you guys to get in the habit of always selecting your residuals. It will build certain types of plots for you. I don't want you to use these. These plots kind of suck. They're also a little bit tougher to tweak or control as easily. And I really want you to understand how you are building up the visualizations that you are making, what they tell you about the regression, and how they help us understand what's actually happening. So I hit OK. And out comes the summary output. I tend to, first thing, go and in home you can reduce the decimal places because, 12 decimal places is just silly. We really aren't that precise in our estimation methods. 2 decimal places is more than enough. So here we have our basic regression statistics up here, and we have our coefficients on both the intercept and on manufacturing. And really powerfully, we also have this residual output at the bottom. So one thing that you'll see, let me get rid of column C here. So here's our original data. I'm going to copy and paste this residual information next to our actual data. We'll move the regression over. What this lets us see is actually kind of cool. Here we can see for each observation in the data set what the model predicts should be its GDP in billions, and the difference between the prediction and the actual, right? So we have the actuals here. Alabama in 2018 had a GDP of $221 billion. The model, this line has a serious residual when it comes to Alabama. It does not represent Alabama well. We can look across all the residuals, and that'll tell us something about how well the model fits. We did this a lot in class. The last thing I'll encourage you to do is actually to build a scatter plot of these two columns, what the model thinks the value should be and how far off that prediction is, the residuals. So just like before, after I highlight those columns, I add a scatter plot, and this is what we call a residual plot. Just to make this a little easier to see, I'm going to get rid of the grid lines. And now what we're actually looking at here is the spread of the error across the values, the fitted values. And you can see these outliers are pretty severe, and there does seem to be a nonlinearity, at least possible here. So to check that a little more formally, I can go into the chart design tools, add a chart element. Just like last time, we're going to add a trend line, but now I want the more options. And I'm going to add a polynomial line, maybe order 3. I really want it to be curvy. Don't worry about the math underpinning this, but this is just sort of a way to visualize the outliers, the effect of them, where the trends might be. Remember, OLS assumes a straight line is the right fit. Very rarely will that be absolutely true, but this can help you to identify where you are dealing with heteroscedasticity in your errors, where you are dealing with nonlinearities that need to be addressed in the regression. So that's as far as we're going to take it at this point in class. Feel free to rewind and fast forward as needed. Use this. Make your own plots. That's the key here. Make your own scatter plot, add a trend line. Make your own residual plot, add a trend line. Okay, see you in class.